Hi Karthik, am I audible?
Yeah, hi Santosh. Yes,
My
and
screen is visible, right?
yes,
Okay, fine. Uh, just a second. Yeah, it's recording. Fine. So let's continue yesterday's class. So yesterday we have seen just a quick summary. Okay, so
yes,
yesterday what we have done. So we have started with the basic method. Okay, which is called
hmm,
as perception trick. Okay, so the task is to classify two different data points, right?
yes, yes,
So over here we have what we have done. So we started with some basic line. Okay, after
hmm,
that we have seen how we can shift it. Okay, so
yes,
because if there are some misclassifications, so obviously you will have those values. Using that you can shift the line. Okay,
true.
so how we are going to shift the line? So we are not going to directly subtract those coordinates. We are using something called as learning rate.
Learning rate 0.0.
Then
Yes.
you are going to shift the line. Okay,
Oh,
so that is fine.
hmm,
But where did we get stuck? The problem is, see, this point, we'll see it once again. So whenever you are, okay, so
If
whenever,
prediction is 0, yeah,
yeah, right.
prediction,
Yeah. So here, so we are having this equation. Okay. So let me just erase
yes,
this. Okay. So we are having this equation over here. This equation. So if we focus on this, this is ya minus ya hat. That means actual minus predicted.
yes,
Okay, so actual you can take anything. So don't get confused that 1 0 or 1 - 1 anything. Okay, so here
hmm,
we are calling this as positive region. This is negative region because two different
yes,
classes. Okay, but over here, so if you see ya minus ya hat, whatever
hmm,
be the cases, okay, the point is if the actual value is same as a predicted value. That means if
true.
your model is whatever the model, the line is predicting the category, the class as exactly as the actual class. So then in
Yes,
that case, this value will become zero. Correct? So if
yes,
it is 1 and 1, 0 or 0, -1 or -1, whatever this value, if it is predicting same as the actual class, ground truth, okay, the value will be 0. In that case, this will be 0, whole thing will be 0, and then we understood that uh,
there is no effect in the weights.
there is no effect in the weights. Now then, sorry,
So
W
it
in will become W0.
the
So
W naught, yeah.
that means this equation, if you translate, so what does it mean? That means the old weights are equal to new weights. That means there is no learning. So when there is no learning, so there is no shifting of the line.
Shifting of the line, yeah.
We'll get stuck here. Okay. So then
So
we also understood what is the main problem over here because
0.
yeah, the prediction is giving us exactly 0 or 1.
Hmm,
Okay. Our labels are 1 and 0. Okay. Now try to
correct.
understand. So if you take any example, so let's say you have uh, one, let me just quickly check if I have any small data set. I'll just show you. Right. Yeah. If I said, let me take this Titanic data set. Okay. So I don't remember whether we have seen this earlier or not. So, but Titanic is okay. This is one use case. Okay, where we have different columns like passenger ID is not useful. Okay, passenger class. Okay, and sex, whether is male, female, and what is his age. Okay, this is some other columns. Okay, what is his fare, ticket fare. The actual, these are the details of the persons who have actually boarded the Titanic when it sank. Okay, so over here, our aim is to predict this one. Okay,
Yes,
survived
yes.
column 0 or
Survived
1.
or not, yeah.
Okay,
Yes.
whether he was survived or not. Okay, and mostly if you see, whenever the mostly the P class, that
High
means
class, yes.
this is lower class. 3 is lower class,
Lower class people
died.
mostly not
Okay,
survived, yeah.
mostly they died. Some higher class people also died, but mostly if you see, the lower class people died. Okay, same like our hero Jack, he
Yes,
died, right? Okay, now if you focus here, what are the two classes of output variable? 0 and 1.
yes,
Only 0 and 1. Okay.
yes.
So this is also one of the classification tasks. Okay.
Classification, yes.
See, we can use, we'll see like how we can use this logistic regression. Okay. But the point is our ground variable, sorry, the actual variable is 1 or 0.
True.
Okay. 1 or 0. Now, oh, sorry, 1 or 0. Now, this is actual. Okay. now when we are predicting, okay, when we are predicting, if it is, if this is also predicting exactly 1 or 0, that is where we are getting the issue. Correct? So we need something that will fall between 0 and 1, but never 0 and 1. And that's where we have learned sigmoid function. Agree? So yesterday, at the end of the class, I was saying you that we have one function called a sigmoid function, as you can see. Okay. So which will be almost equal to 1, almost equal to 0, but never 1, never 0. It will be always ranging between 1 and 0.
Yes.
Okay. Fine. So now the equation of sigmoid function is this one. Okay. That means what? Whatever the x you are going to give, okay,
Mm-hmm.
it will do this function. That means
Correct.
earlier till now, what we have done with x. So we have this one, right? So we did wixi, if you remember,
Yes.
wixi. This is a
Yes.
simple,
Summation. Yeah.
okay. Whatever the value you are putting it over here, okay, that is the if you solve that, that is the value we are going to get. But now we are not doing that. So we are passing our value to here. Okay. So whatever the input you are going to give here, so you are going to uh, pass here. No, sorry, I told you wrong. We are not passing our equation over here. Okay. So whatever
Okay.
the value you are going to get, right? So that value you are going
Mm-hmm.
to put here. Okay. Fine. So
Okay.
yeah. So we'll see. Initially, the sigmoid function is 1 by 1 plus e to the power of minus x. That means whatever the value you give here, let's say 0. So it will solve and it will give some number. And this number, okay, no matter whatever x you give, okay, no matter whatever
Okay.
x you are going to give,
Mm-hmm.
and if you solve this 1 by 1 plus e to the power of minus x, this value will be always between 0 and 1. That is the meaning of
True.
this. Okay,
True.
fine.
True.
What value we are going to give here? The same value, whatever we are going to get it from wixi.
Okay.
Okay. Earlier, we are using directly wixi. Okay. This used to give us exactly 0 or 1.
Yes.
Correct? So now
Yes.
we are putting one more layer. We are saying, hey, no, I don't want like this. I will take whatever the value you are going to give here. Okay. That value, I'll just give it to sigmoid function so that it will give me an output that is in between 0 and 1. Okay.
Yeah.
Yeah. So if you see, for example, if you see, uh, earlier what we are doing, so we are doing W0, X0, W1, X1, whatever you are doing, right? W0, X0, W1, X1. So earlier, this is going to give us a step function kind of thing. That means either it is step function means either 0 or 1. Okay. If it is less than 0, 1 class, greater than 0, 1 class. That's it. Agree?
Yes, Santosh.
Okay. But now, whatever the Z we are having, right?
Mm-hmm.
That Z, we are going to pass it to the sigmoid function. Okay. Sigmoid of Z.
Okay.
Sigmoid of Z. Fine.
Yeah.
Yeah, correct. So that means what, in essence, whatever the value, this x value, right? So wixi, correct?
Mm-hmm.
See, that means if you are having like 2x plus 3y as an example, okay?
Mm-hmm.
So for x and y, you will have some coordinate, right? So you will
Yes.
solve this
Yes.
value.
Yes.
That value, you will put it over here.
Okay. Okay. Got it.
Okay? That value, you will put it over here. Okay?
We'll put it in place of X.
In place of x. Okay.
Yeah.
Sorry if it was if I told it the other way. Okay. So earlier what we, yeah, let's understand it clearly. So earlier whatever the wixi we are having, right? So we are
Mm-hmm.
just solving it, and whatever the value, if you solve it, if it is greater than 0, you are saying, hey, it
Mm.
is one class, and if it is less than 0,
Less than zero.
you are
Yeah. Another
saying
class.
it is another
Term
class.
class. Yeah.
Okay. It is another class. Okay.
Mm-hmm.
But now instead of doing that, instead of doing that, what we are doing, we are putting whatever this is there, right? This is called as Z,
Yeah.
right? WXI is Z. That Z, we are putting it over here. Okay, that
Yeah.
means you will solve this. Okay, you will get
Mm-hmm.
some value. Okay,
Yeah.
but that value, if it is positive, you will not say directly 1. If it is negative, you will not directly say 0. But we'll put it over here and solve this equation, and then based upon the sigmoid function, we'll take that value. Okay,
Okay.
we'll see that. Okay, same thing.
Here,
So instead of using, yeah, tell me.
yeah. So here it will be always 0 to 1, right? Value.
Correct, correct.
Okay. Then yeah, just I have doubt. If
Yeah,
we look at the graph, it will be negative side as well, right?
correct.
Yeah.
No, the value, no, these are the x values, right, Karthik?
Yes, yes, yes.
Yeah. So you are saying the value could be 0 to 1. No, for example, I got your point. So I'll show you. Um, right off 0. Sigmoid calculator.
Mhm.
Over here, if you see,
Mhm.
if you take sigmoid of 0, okay, this is
Mhm.
sigmoid. This is derivative of sigmoid. Okay, you don't.
Yeah, yeah, yeah.
If
Yeah.
sigmoid of 0, it is 0.5.
Correct.
Okay, so
Mhm.
if I go for 10, so you'll get 0.99999.
Yeah.
Okay,
Mhm.
if you go to let's say minus 10, we'll get 0.0000. Okay,
Yes.
so here also the y value is the output, right? So if
True.
you're if you're confusing with this, okay, see, understand this. This is 0. Okay,
Yeah.
this is
Mhm.
x-axis.
Correct.
For example, you take any point over here.
Mhm.
What is the, for example, let's take 0. Okay,
Mhm.
if you take 0, that means what I'm saying, x equal to 0.
Correct.
What is, you see, it's fundamental y equal to f of x, right? You know
Yes,
this
yes.
function, any function is
Yes.
y equal to f of x. Whatever the
Yes.
function, simple y. That means what? You give x value,
We'll derive
you
the
get the
y.
y value,
True.
depending upon the function. If it is sigmoid 1 by 1 plus e to the power minus x, if it is exponential e power minus x, if it is square root of x, square x square, whatever be the function, you give x, you solve that, you will get y value. Agree?
Correct. Correct.
Now, now see, this is 0, x
Mhm.
is 0. Now, if x is 0, what is y value? That means what? Where, if x is 0, you extend that where it is pointing on the graph. Here it is pointing.
Correct.
What is this? This is 0.6, this is 0.4, this is 0.5.
True.
Correct?
Correct.
Now, you are increasing the value of x. You are increasing. Okay, whatever the value you take here, 4. What is the value over here? Here it is 4, and that is x value.
Yeah.
But what is the y value? Y value is 0, almost 1,
Fine.
but not 1,
Yes.
0.09.
Correct.
Okay, this 0.09 is coming from where?
From where means from, I mean, after derivative of
From the sigmoid function.
yes,
After,
yes, after derivative of
after
sigmoid
you
function.
put
Yes.
this 4 over here,
True. True.
you will get this. Similarly, you
Yeah.
come to this side. Okay,
Mm-hmm. Mm-hmm.
when you, so first of all, when you are starting with 0 and slowly you are increasing 1, so the value is at 0 it is 0.5, at 1 it is
Correct.
0.7.
Correct.
Slowly the
Correct.
value is increasing, but it is
True.
never 1. Similarly, when
Yes.
you are decreasing, so these minus values are x values, but what are
Yeah.
the
Yeah.
y
So
values
now
here?
on
Y
the
values
top of
here,
side also y value should be okay.
yeah, yeah. Over here also the y value is when you are at 0, 0.5, at minus
Mm.
1, it is somewhere around 0.3. At minus 2, it is somewhere around, here it is touching, right? So it is somewhere around 0.18 or not 0.1. Okay. And somewhere
Okay.
here it
Got
is
it.
this. But at 0.4, even if you take, it is almost equal to 0. That means,
True. 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 Zero point zero zero
yeah,
zero
this
zero 0.0001.
vertical line, see, sorry.
Yeah.
This vertical line should be your value. Okay, this is the value. This is the value. So here it is almost 0, but
Correct.
not 0.
Correct. Okay. Got
Correct?
it. Got it. Yes.
Here this is the, these are the values. These are the values. So here it is almost 1, but never 1. Is it
Yes.
clear? So sigmoid is not going to give negative values. These negative values are x values, Karthik. Okay.
Okay. Okay.
The wherever the line that is touching on the this curve, those are the y values. Those are sigmoid values. So that will always be equal to between 0 and 1, because this line is 0 line, this line is 1 line. The graph will always be between 0 and 1. Is
Okay. Yes.
okay. So now coming back, so what we are doing is, earlier when we are just solving this and taking if it is greater than 0, 1, less than 0, 0, okay.
Mm-hmm.
But now what we are doing here is, we are not doing that. So we are giving this equation to sigmoid.
Okay.
Okay. So that means what? First, we will solve this. After solving, we will not blindly say this. What we'll do, we'll give that equation to sigmoid. Now, sigmoid will do its calculation and it will say if it is greater than 0.5, one class.
Mm-hmm.
Okay. Because greater than
Mm-hmm.
0.5, you will get one class. And if it is less than 0.5, I'm considering another class.
Got it.
Okay. Because why? At 0.5, my value is 0.
Yes, yes.
Okay. At
Yeah.
0.5, sigmoid value is 0.
Yes.
As per graph, you can clearly see.
True.
Okay. So I'm saying if the value is greater than 0.5, one class. If it is less than 0.5, another class. Clear? How I'm
Yeah.
going to get that value? Again, simple. Okay. So same thing. So you will get, assume that you already know these W values. Okay. How you will find out these W values, we'll see. Okay. Assume that you started with some random value. Now, what are these X1, X2, X3? Those are your input values like X, Y, Z in two-dimensional
Yeah.
X and Y. Okay.
Yeah.
Those values you are having, you just take this and just pass it to sigmoid function. It will
Yeah.
do the calculation and it will solve this, and whatever the value it is getting, right?
Hmm.
The job of, see, it is very interesting to understand here. The job of sigmoid function is to just give you a value of that
True.
that thing,
Yeah.
0.5, 0.2, 0. Whatever it is. Now we are saying if it is greater than 0.5, one class. If it is less than 0.5, zero class, I'm saying. Okay, because at 0.5 the class is 0. Correct? At 0. If the value I'm getting is 0.5,
Yeah.
okay, uh,
Hmm.
fine. Sorry,
Yeah.
when if the value is 0,
Sigma function is
yeah,
0.5.
at 0.5 it is 0. So if it is greater than 0.5,
Mm-hmm.
okay, I'm saying one class. If it is less than 0.5, I'm saying that. But
Yes.
later we will see whether we can have this 0.5 fixed always or not. Okay. So just remember this. Okay. So we are saying this sigmoid function is not saying this. Sigmoid
Mm-hmm.
function is just giving you a value 0.5,
Yeah.
0.3, anything.
Mm-hmm.
Based
Hmm.
upon that, we are saying, okay, we have two classes. Greater than 0.5, I will take one class. Less than 0.5, I will take another class.
Okay.
Okay, fine.
Hmm.
So now, again, same thing. Now what happened? Yesterday, how we are doing? So now we added one more layer. Now again, what we'll do?
Okay.
Just imagine we have all the points. Then you
Hmm. Four
started with
points.
some random line. Okay.
Yeah.
So with that random line, you have W1, X1, everything. Okay. You take that line
Yes.
equation and now put it into sigmoid function. Now sigmoid
True.
function will for each point. Okay.
Yeah.
So
Yeah.
what is this? This is for one point. W1
Hmm.
xi is for one point. If it go to another point, it will become some other W3 x3.
True. True. True.
For every point you take it, so put it to this equation and give it to sigmoid. Sigmoid will
Mm-hmm.
give you an output. Based upon that,
Yeah.
if that output is greater than 0.5, I will say
One class. One class.
one class.
One first. Yeah.
If it
Per
is
class.
less
Yes.
than 0.5, zero class.
No.
Agree?
Yeah. Yes.
Clear?
Clear.
Huh. But here also, again, the same thing. Yesterday
Mm-hmm.
also, when we are saying this part, so when we are saying, if you remember this one, my
Yeah.
model, whatever sigmoid or whatever the thing you are saying, that is giving you one value. But whether that
Yes.
will be exactly equal to the actual ground truth or not, I don't know, because here also there could be misclassifications.
Okay.
Agree? So here
Mm-hmm.
also sigma, the only difference what we made here is very simple. Instead of
We are not getting zero here.
directly, instead of considering 0 and 1, we put one person in between sigmoid so that we are controlling that like a knob. You can
Yeah.
think
Yeah.
like a knob, right? So we can control this values between 0 and 1 so that this equation will never fail. This will always keep running, right? This will never become 0. It will
Yes. We'll get
go on.
something new. Yeah.
Correct. But again, the same thing will happen. Only sigmoid, now instead of directly giving, sigmoid is giving the values. Based upon that, we are
Yes.
classifying, hey, 0.5, we are putting threshold. Okay, this call as threshold,
Yeah.
0.5, and above one class, below one class. But
Yes.
just because we are putting sigmoid, no
Mm-hmm.
guarantee that we are 100% correct, right? So sigmoid is saying, now our model is sigmoid, let's say. Okay, now model is saying, okay, the value is greater than 0.5. For example, I got 0.8. So greater than 0.5. So I'm saying it is positive class
Yeah.
for a particular line, for a particular line. Okay.
Yes.
But actually that class could be negative class.
True.
Correct. So for that again we'll shift it. In new line will come. New line again
Hmm.
we have WXI. That, again you will
Hmm.
put that into sigmoid. Again sigmoid will give you some value. You will again decide greater
Hmm.
than or less than 0.5. Again if it is
Yeah.
perfect classification, it's fine. But again the shifting will happen. But one
True.
difference you need to understand here is here shifting will never stop.
Correct.
Correct. Earlier there
Correct.
is chance of shifting stopping because
Yes.
of this getting zero. But
Yes.
here, no matter whatever the value you get, this value is never going to be zero. It will be between
True.
0 and 1. So shifting will never stop. So it will, we are giving opportunities at it will constantly adjust itself.
Yes.
You are able to get it?
Yes. Yes.
Okay, fine. So that is what we are saying. So here also we are saying the whatever the value z is like w0x1. So that value, you are, yeah. So here you see two things. One is if z is greater than 0. What is our z? That is actual label. So if that is greater than
Correct.
0, that means what? It is a positive class.
Hmm.
And my sigmoid of z is also greater than 0.5, then also
Yeah.
positive. That means label 1. That means positive.
Hmm.
Okay. Now, if z is less than 0 and sigmoid is less than 0.5, that is all, that is negative.
Yeah.
Okay. Fine. This we know. Now, few things we'll understand. With the entry of sigmoid function, one advantage is that output is always between 0 and 1, which means we can consider this as a probability, and any value you give, it gives out the probability between 0 and 1, which means even for a negative point in positive region, we get some value. Okay, this is very, very important point, Karthik. Okay, see here. If you understand this one, right, so everything will be very easy. If you gets confused here, it will be very difficult. Okay, see here, focus.
Mm-hmm.
I'm saying the sigmoid is giving you probability.
True.
0 between 0 and 1. It is giving 0 and 1.
True.
We can consider it as probability because even probability is also probability could be 0 and maximum value of probability is 1. Okay,
One.
probability is
Yeah.
greater than 1. Okay, so
Hmm.
this sigmoid I will consider, we are considering it as probability. Okay,
Mm-hmm.
now when there is some point, okay, there is some point, this point value you took, you did wixi, then that is called z. All right, z you
Mm-hmm.
passed into sigmoid, sigmoid
Yeah.
gives you some value. Now
Yes.
this if I calling the probability of some x, one
Mm-hmm.
second, yeah, yeah, probability of x, if I got it like let's say 0.7,
Mm-hmm.
that means if it is, for example, you get it, if you get the probability equal to 1,
Mm-hmm.
okay, that means what, it is belonging to class 1, the upper
Yes.
class.
Yes.
If the probability is decreasing,
Mm-hmm.
correct, if the
Mm-hmm.
probability is decreasing, that means the probability of that point to belong to class 1 is decreasing.
True.
Okay. Now, you see, it's a slightly tricky thing. Okay. You need to
Mm-hmm.
understand this. So, when I'm saying probability of x, some other point, okay, this is x1. Okay. This is x2, Karthik. Okay.
Mm-hmm. Mm-hmm.
Here I'm saying probability of it is 0.2, for example, some other point. Now, see,
Mm-hmm.
for x1, I'm saying probability is 0.7.
True.
The maximum probability is 1. But now
Yeah.
probability of x1 is 0.7. That means the probability of this class, okay, the
Mm-hmm.
probability of this x1 to belong to class 1 is 0.7.
Correct.
Now, what is the probability of this x1 to belong to class 0?
0.3.
0.3. Okay,
Hmm.
correct. Now, coming to this point, here also, when I'm saying probability of x2,
Mm-hmm.
that means what? The probability of x2 to belong to class 1
Is
is
0.8
0.2.
for class 1. Yeah.
Correct,
Yeah. Yes. Yes.
correct. Yeah, that means whatever the
Near to 0
probability,
point. Yeah.
whatever the
Near to 0 this
probability,
one.
correct. Whatever the probability you are getting, those are the
Yeah.
probabilities to belong to class 1.
Correct. Correct.
Correct?
Correct. Hmm.
That means, irrespective of this class, these see, this x1 could be actually belong to positive class or negative class, x2 can belong to positive class, negative class. That is separate thing. We are
Hmm.
speaking from the sigmoid probability perspective. The sigmoid is
Yeah.
giving you a value, whatever the probability it is giving, right? So if it is mag 1, that means this particular point, whatever you're considering, its probability to fall into class 1 is 1. If it is 0.9, it's 0.9. It's 0.8, 7, it is 0.7. If it is 0.2, that means this point x2 probability to become a
Hmm.
class 1 is 0.2.
Hmm.
Correct?
Hmm.
Correct. Now you see. It did not end here. Now you'll understand. So here, if x1 0.7 for
Mhm.
class 1, I'll put
Correct.
okay, comma.
Correct.
That means what? That means here interesting point is I wrote here, which means even for a negative point in positive region also you will have some value. Even for a positive point in negative region also will have some value. That means what? See, here in sigmoid, as we
Mhm.
already know, it is never telling you 1 or 0. It is saying you 0.099999, right? So that
True.
means what? For example, here 0.7 positive class 1 means remaining 0.3 class 0.
Mhm.
That means if you take some other point whose probability is 0.999, that means it is having 0.0001 probability to fall into 0 class.
Yes.
Similarly, here, for example, this probability of this class is 0.2. That means what? You should understand.
0.8% should fall under class 0.
Correct. So here, the remaining 0.8 probability is for class 0.
Yes.
Correct. So one fundamental thing you need to understand is for mainly in the binary classification, logistic regression, the sigmoid function
Mhm.
will always give probability of the positive class.
Class.
That means class 1.
Yeah.
Okay.
This is completely after after we got z value, and that z
Correct.
value is
Correct.
uh, what we have given to sigmoid function,
Correct.
and the sigmoid function
Is
provided the
the
final value.
value.
That is the value. It's a p value,
Yeah,
probability value.
correct. That value is the probability value, and that
Yeah.
value is
Always towards
speaking
the
about
speaking
uh,
about class 1.
class 1. Yeah. So you should not think, for example, let's say you got to know this is a negative class, Karthik. Okay. X2 is
Mm-hmm.
negative class, from the data set. You gave to the
Okay.
sigmoid function. Sigmoid gives 0.2. So you should not think the sigmoid is talking that the probability of this X2 to fall
Zero.
into class is
Zero.
0.2. No.
Because though I mean though it is a negative class, we should not go towards the class 0. We always think about class
Yeah,
1.
correct. Correct. Whatever the sigmoid is giving, that is about the class 1.
True.
Okay, whatever the sigmoid is giving, that is giving for the class, because it cannot give two values, right? So it will give you only
True.
one
True.
value.
True.
That
True.
value, if it is 0.5, it is 0. I'm saying if it is maximum value, that will become class 0. But if it is
Hmm.
negative value, that means the
Mm-hmm.
probability of getting into class 1 is 0. Okay,
Got it.
fine. So now, if you see here, which means there, and so now this is just for your understanding, I have written here. So what happens here is earlier in yesterday's class, when we are having a misclassification, so 2 points will start pulling the line towards itself, right?
Hmm.
Now what will happen in sigmoid function? What happens is, um, see, for a correctly classified point, if a point is nearby, so that means, for example, you have something like this one, and there is some line, and let's say this is a correctly classified point. Okay,
Mm-hmm.
if a correctly classified point, okay, is nearby the line, it will strongly push the line. Okay, see, it is simple logic. So for example, this is a line, okay, and
Mm-hmm.
here we have a correctly classified point. This is also correct classified point. Okay,
Mm-hmm.
now this point is anyhow far away. It is
True.
already happy, so it will not. So but both of this goal is to be as much far away from this point. Correct,
Mm-hmm.
because this side is
Mm-hmm.
positive region
Hmm.
and these two are positive points. So
Yes.
these two goals should be as much far away. That means they will be more happy if they are here, because they are deep inside the positive region.
True.
Agree? But what happens is, because this is very much closer to it, okay, it wants to be move away from it. So that's why it will push
Yeah.
the line strongly,
Got it.
push the line away from it. Okay.
Hmm.
This is
Mm-hmm.
anyhow a little far off, so it will not push that strongly. Okay, same thing. So
Correct.
correctly
Correct. Correct.
classified point, if it is nearby the line, it will push strongly. That means
It should not fall under negative side.
not
That's
fall,
why it
correct,
will push.
exactly. But if it is
Hmm.
far off, then it will slightly push away because it is
Because
already
yes,
from safe.
no need to worry. Yeah.
Correct?
Yeah.
But
Right.
coming to a wrongly classified, for example, I will take another color. So let's say it is a wrongly classified point. This is also wrongly classified point. Okay. So
It will pull.
yeah, correct. Far off will pull strongly because this guy is
True.
also misclassified. This guy is also misclassified, but this guy is more misclassified. Correct.
Correct.
So this guy will
Yeah.
pull more strongly.
True.
This guy is also classic misclassified.
Slightly pull.
it will
Slightly pull.
okay. So if it is nearby, it will pull slightly. If it is far off, it will pull with strong force. Okay, how that will pull means again the same thing. The coordinates system will come into picture. Okay, with
Yeah,
that a new line will come. Fine,
got it.
clear, fine. So now this is just for understanding, but going back, the sigmoid function we understood, and what is the probability what we are getting is we understood. Okay.
Yeah,
Now,
yeah.
what is if you just stop for a second and think what is our goal which we have started. So we started with how to classify. So we got the line.
Mm,
After that, we introduced
mm,
sigmoid function. Now we
mm.
don't need to manually do anything. Any point you give, okay. Just like Titanic example, you take any particular row. One row is 1 point, right? Take that point, do WXI, put into sigmoid. It will give you a value you got. Okay.
Yeah,
But earlier, why did we stop? Earlier, we stopped because of two reasons. One is this reason, that means
yeah,
we are getting stuck. Assuming
yeah.
that even if you don't get stuck, also, then what is the other problem? Other problem is this one. So even though it will stop at not at the best solution, at
Mm,
particular position where it segregates both the points correctly, it will just stop at that point. It will not
true.
go for the best position, which might be like this, right? Yesterday
Mm,
we were discussing. Now we came across sigmoid and we introduced few things. Now, can we say that we are at the good solution? No. Okay, because
mhm,
we'll see few things. Okay, fundamentally, what happens here is in any machine learning algorithm, what you will see is a loss function, Karthik. Okay,
mhm,
so that
mhm.
means what in ML there should be some goal for ML. Okay, that
Okay.
means in linear regression, because you understood linear regression, so it is it will be easy for you to understand other algorithms. So in linear regression,
Okay.
what we did, we had some loss function. What is loss? Like how each point, how much it is distant from the best fit line, that those are the losses. We did the
Yes.
square of that loss,
Yes. Yes.
and
Yes.
our goal is to minimize this loss.
True.
Since we have a goal, we already have gradient descent. Its function is to find out the minimum, find out those values for which a given function will have the minimum value.
Hmm.
Gradient descent job is only that, right? So
Yeah.
gradient descent is always asking, hey, you give me some function, any function for which you want a minimum value.
True.
Okay, then I can just give me that function. I will give you the values for those values like m and b or w1, w2, such that if you use those values, then you will get a line. That line
Yeah.
will
But
give you the
that
minimum loss.
true. And that is the best fit line. Yeah.
That is the best fit line in linear regression.
True.
Here also, our goal is to find out a line only. But
Yeah. Line.
it's not a best fit line, but line which will perfectly segregate, or at
Segregate.
least
Yeah.
not perfectly segregate, at least which will have the least
Minimum loss. Yeah.
minimum loss. Agree?
Yeah.
Here, loss
Hmm.
is what? Doing least number of misclassifications.
True. True.
Correct? Here also we do.
Yeah.
So that means what?
So less number of data points should be fall other both the
Correct.
sides.
Exactly.
Hmm.
Exactly. So
Hmm.
less number of positive should be in negative region. Less number of negative should be
Yeah. Number negative should be positive. Yes.
okay. So fine. So now that's the reason we need some automatic process. So we don't want to do it manually, because here sigmoid
True.
function is fine. Okay. But
Yeah. Yeah.
again, you need to do manually. How many times you will do? Even if you
Yeah. Yeah.
1,000 times also, you might get
We
or
are
you
not sure. Yes.
okay. So that's why any machine learning
ML.
algorithm, you will have something called as loss function. Okay,
Yeah.
you have that loss function, your half of the job is done. Then you don't
Okay.
need to do anything. So you are saying I have this loss function, and my aim is to have minimum loss. That's it. If my this function is having minimum loss, that
Mhm.
means whatever the model I am going to get, that is going to have best accuracy.
Okay.
How do we get the minimum loss? You have gradient descent anyhow. Okay.
Hmm.
So now clear till this point.
Yes.
Okay, so now, so basically, yeah, as I said, basically this ML will not rely on this randomness. So what it will do is it will ask for some loss function.
Last
Okay?
function. Yeah.
But to understand loss function, so we need to slightly divert and understand few concepts. Okay,
Mhm.
so we'll understand
Mhm.
those small two, three concepts, and then we'll come back. We'll get the loss function. Okay, one is maximum
Okay.
likelihood, Karthik. Okay,
Okay.
so what is
Okay. Okay.
maximum likelihood is same thing.
More
Yeah, no,
same
no.
number of data points.
No, 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 no.
Okay.
No, we'll
Okay.
see. Similar, but wait. No, don't make
Okay.
assumptions, because this
Sure.
particular point you understand, right? So it is related to that. So maximum
Hmm.
likelihood will say. So till now, what we understood. See, these 4 points are important. Even for a correctly
Mhm.
classified points, there is some probability of getting misclassified. This you understood. That means probability of correct. Okay, that means probability of getting into class one if it is 0.9. The probability of falling into zero will be 0.1.
True.
Similarly, the probability of if incorrect is 0.6, if it is, let's say 1, the remaining will be 0.4. But
True.
fundamental thing is, it is always important to note that, okay, in linear regression, the prediction will always be the probability of the positive class. Okay,
Mm-hmm.
never be the negative class. Okay,
Okay. Mm-hmm.
so that's why what we always want, high probabilities of positive class and low probabilities of zeros class. Sorry, high probabilities of ones class and low probability of zero class. That means what? So this is very important. Okay, see here. For example, you are
Mm-hmm.
having positive class
Mm-hmm.
points here.
Okay.
Okay, you already know what are positive class points. These are all positive class points, right? That means whenever
Yeah.
you're having one, 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 one.
Yes. Yes.
Okay,
Yes.
these are all survived class.
Hmm.
Okay, all these 0 points, these are all negative class or
Negative
zero
plus.
class. Okay, here from training data, this is during training only. Okay, all we are doing
Yeah.
is
Yeah.
training. Testing will come later. You know that, right?
Yeah.
Okay.
Yes.
So you have positive class, you have negative class. Okay.
Mm-hmm.
So this logic you understand. So when I'm saying this particular, take 1 point from this positive set data. Okay. And you do this, you send it to sigmoid, WIXI, Z, WIXI, sigmoid. Okay. These things, I think you are good by now, right?
Mm-hmm.
To get the
Yeah.
value. Okay. Directly I'm writing this probability. That means when I write this probability of, okay, some x1 is equal
Mm-hmm.
to 0.9, you need to understand in the background what happened. That means I took this
Yes. Yes.
x1,
Yes.
did
Yes.
WIXI, which is called Z. That value I sent it to sigmoid. Sigmoid is giving some value if it is greater than 0.5.
Yeah.
Yeah, till now, okay. As of now,
True.
this is the value I got it from sigmoid.
Yes.
Because it is greater than 0.5, anyhow, I am going to categorize it into positive class. Okay, that is
True.
fine. Okay, but we did not do that. Just assume this is the value I got it from sigmoid.
Yeah.
Now, the point to understand is, for a positive class points,
Mm-hmm.
this value should be maximum. Why?
Okay.
Because this xi is a positive class point.
Hmm.
That means its probability of falling into 1 should be maximum.
Yeah.
Only then the probability of going into 0 will be minimum.
True.
Correct? So that's why for a positive class points, the high probabilities of 1 should be maximum. Okay, so we decide whatever what any point you take from this, okay, probability of x1 or x2, any value, the
Mm-hmm.
value whatever you're going to get from the sigmoid, that should be maximum. Okay, or
Yeah.
0.8, 0.9, anything.
Yeah.
Okay, this is fine, this is clear, but the
Mm-hmm.
main thing is here. Okay, if you see here,
Mm-hmm.
this is negative point. That means
Yeah.
what? These points. Okay, 0, 0, all these zeros. Okay, so
Yeah.
further also you will do the same thing, and now probability of
True.
from the sigmoid you are getting, okay, x1,
Hmm.
negative point x1. Here,
Hmm.
whatever the value you are going to get, that value should not be maximum. Okay, because
Hmm.
for example, let's say I'm getting maximum. Okay, for example, assume I got 0.9. Let's try to understand.
Mm-hmm.
Now my sigmoid is saying 0.9.
Hmm.
That means what? As per
Towards class
sigmoid,
one.
the probability of this x1 point to fall into class 1,
Class one is
0.9.
0.9. Hmm.
Okay, that means it is saying it is having high probability to fall into class 1. That means it is a positive class point, is what sigmoid is saying.
Correct.
Correct? That means what? We are going to categorize it into positive class.
Hmm.
It became positive class, but actually it is negative class.
Yeah.
Correct? So there is misclassification happening.
True.
Correct? So that's why for a negative class point, whatever the probability you are getting from the sigmoid, that should be low. Okay.
True.
So for example, if you get 0.2, that means what? It is giving you in the reverse way, if you just
Hmm.
understand. So sigmoid is
Yeah.
saying, "Hey, the probability of this point, see, the sigmoid does not know it is positive or negative point. You understand?
Correct. It's just giving a value. Yeah. It's our
It is
complete
saying
value.
whatever the value, whatever the point you give me, for that point, the probability to fall into class 1 or positive
Yeah.
class is very, very low, 0.2. It is saying.
Hmm.
That means what? This is for
It is
positive
more.
class. That means what?
Yeah. More
The
chances
remaining
to fall
0.
under negative.
The remaining 0.8 probability is for the negative class.
Correct.
That means negative class
High
probability is
chances.
low. So
Yes.
we are directly putting it into negative class. So
Got it.
actually is negative, this is a negative. Getting?
Hmm.
So
Hmm.
that's
Hmm.
why
Hmm.
that's why for a positive class, we always
Mm-hmm.
want high probabilities of ones. That means wherever you are
Yeah. Yeah.
having one, right? So these ones, that means positive class in
Mm-hmm.
other way. We want high
Yeah.
probability. But for
Yeah.
zero, but for the negative class, we want the low probabilities.
Yes.
Because always remember, we are only the we always give only positive class probability from the sigmoid function. Okay.
True.
So you can understand it
True.
two ways. One is directly you can say, hey, if it is less than 0.5, you are saying it as negative class. Why you are saying
Hmm.
negative class? Because if it is less than 0.5, small values is negative class, because for those values, the negative class probability is
More.
getting more. The more you are
Yes.
decreasing this value from the sigmoid, if it is 0.1, what is the
Yes.
if you are getting 0.1 from sigmoid, that means it is 0.9 for the negative class probability. Okay,
True. True.
sigmoid is
True.
not giving that. Okay, so
Yes.
that's why if whatever the positive class you get, right, you need to get maximum values from sigmoid so that it is perfectly classifying. And whatever the negative class you are giving to sigmoid, it should give you the least values so that the opposite values of negative class will be maximum. Okay, so that means it will become negative class.
Yes.
Correct? If this is happening, that means perfect classification is happening. Okay.
Yeah.
If it is other way around, that means if for positive class, if it is giving less than 0.5 values, or for negative class, if it is giving greater than 0.5 values, that means misclassification is happening.
Yeah.
Is this clear? Any doubts?
Clear. Clear.
Okay, cool. So now coming to this maximum likelihood is what? So maximum likelihood states that to multiply all the probabilities of
Mm-hmm.
points, okay, of points, but take only those probabilities that the point actually is. Okay, so simple. So this is might be confusing. So what does it means? So if you, for point 1 x1, okay, you are having
Mm-hmm.
x2, you are having x3,
Mm-hmm.
for example. Okay, so you send
Mm-hmm.
the probabilities, and p, I'm saying sigma, let me write this is a sigmoid symbol, Karthik. Okay,
Mm-hmm. Mm-hmm.
you know, right? So here sigmoid.
Yeah. Yeah. Sigma.
Okay.
Yeah.
So sigmoid, I passed each of this value. Okay, so this one,
Mm-hmm.
let's say this is positive, negative, positive class. Okay, so
Mm-hmm.
for this I'm getting, I don't know, for example, I got 0.7, I got some 0.3, and let's say 0.9. Okay, these are the sigmoid values. Now the maximum likelihood is saying multiply the probabilities, but not these probabilities. Don't directly multiply whatever the
Yeah. Yeah.
probability
Got it.
in sigmoid,
Got it.
but
Yeah.
only that the point actually is. Okay, so what does that mean? So this probability, this point is 7. Sorry, this point is positive point. Okay.
Yeah.
So this is also positive probability. So
True. True.
you'll do 0.
0.7.
You'll do 0.7. Okay.
Correct.
Into, now this see, this is going to be always positive probability, as you know. Okay,
True.
sigmoids. Okay. This is fine. But now this is 0.3. But is this positive point? No, this is negative point.
Negative side. Yeah.
Need to take the probability that the point is actually is. So you need to
Mm.
take the negative probability. So what is the negative probability of this 0.3?
0.7.
Correct, 0.7. Perfect. And into, this is anyhow positive probability.
0.9.
This is 0.9. Okay.
0.9.
This
Yeah.
probability, this is the probability. This is called the maximum likelihood.
Okay.
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 Because if you use this value, maximum likelihood is means what? The reason why we are called the maximum likelihood is whatever the value you are going to get, we want to get maximum value. That means
Yes.
if that value is maximum, the better the model is. Okay.
Yeah.
That's the reason we are taking this actual probability, because if you take 0.3 only, this value will
Mm-hmm.
decrease, right?
Yeah.
For example, a particular point you are having, it's a perfectly negative class. If it's a
Hmm.
perfectly negative class, what will be the value of this could be? Can you tell me?
Perfectly negative class.
Uh, so what will be the probability from sigmoid?
That is
No,
0.8 only.
no. For a negative class, okay,
Mm-hmm.
what will the probability from sigmoid? Whether it will be high or low?
Low.
Low, right? So
Yeah.
that
Yeah.
I'm saying if it could be 0.1 or 0.0.
0.0. Yeah. 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 Yeah.
Okay?
Correct.
The
Hmm.
more lower the value, that means the more perfectly it is classifying. The more
True.
strongly it is saying that it is a negative class. Correct?
Yes.
So
Yes.
I'm saying, for example, if this probability is 0.01, okay,
Mm-hmm.
use directly 0.01, this whole value will is decreasing.
Yes.
You not
True.
get maximum value, you get minimum value. So that's why we're
True.
not doing this. So if it is 0.01,
Mm-hmm.
that is, so we are understanding, okay, this is the probability that sigmoid is saying. That means it is a positive class
Correct.
probability. The
Correct.
the remaining probability will be 1 minus 0.01. So
True.
we'll do 0.9999. 1 minus
Yeah.
0.999 into 0.90. Okay.
Correct.
So if this value, whatever the value you are, whatever the probabilities you are taking, the actual probabilities, not the sigmoid
Hmm.
probabilities,
Mm-hmm.
okay?
Hmm.
Actual probabilities. That means what? Only for negative values you need to change. For
Yeah.
positive,
True.
anyhow, directly you are using, as you
It's the
can see.
same. Yes. Yes.
For negative, you will change, and whatever, and you multiply those values.
Hmm.
That value, if you are going to get, if
Okay.
that is maximum,
Mm-hmm.
then that is a good model. That means what? Simply, you are having two lines. Okay,
Yeah.
simple. Okay, see. Now you will understand. Okay, now you are having, for example, I will just use, did we have, yeah, here only you are having one line. Okay, let
Yeah.
me say this black color is one line, and
Yeah.
some other, this is another line. Okay,
Mm-hmm.
for this line also, what you will do, take every point, do z, do sigmoid, you will get some value, and you will get some maximum likelihood multiplication value.
Mm-hmm.
Agree?
Mm.
Because, and for this one also, you will do some other. Okay, but which of this line is going to give you maximum likelihood value? So that line you will consider it as the best fit line. Okay.
Okay. Okay.
For example, this line is doing, for example, you have this line and some other line is like this, doing one misclassification.
Yeah, got it.
Okay. So you,
Whatever, there are many number of lines, though if you are getting the maximum likelihood, that is the line will be the best line.
correct.
Yeah.
Okay. So same things. For example, if you see here, this is a positive class.
Yeah.
Okay. For a positive class, what is the probability of positive class? 0.8.
Yeah.
It will have negative class probability also 0.2.
True.
Fine, keep it aside. This is a negative class. For negative class, what is the probability of positive class? That means this is what you are getting from the sigmoid. That is 0.3.
Mm.
Remaining will be 0.7. Now,
True.
the maximum likelihood will be, okay, for this
Zero
positive
point 0.8,
0.8 into,
0.7,
correct, into 0.7. So 0.8 into 0.7. Okay, that is maximum likelihood. If you have 10 points, you will use ten multiplications.
10 positive. Yeah.
Similarly, so if you give two lines and if you need to find the best line, which we can say use, we can simply say maximum of likelihood, whichever the line that is giving, choose that line.
Okay.
Okay. So we are close to the final solution, but can we stop
Mm-hmm.
here with the maximum likelihood? No, because everything is fine, no issue. But the problem here is usually it is difficult to find a maximum value when compared to minimum value. Okay.
Okay.
In
Okay.
maths, in calculus also, mostly we'll find a minimum value of a function. What
Yes.
is
Yes.
minimum value? But maximum
Yes.
value, it is a bit difficult because maximum could be anything.
Yes.
Correct? So instead of saying I want to find out the maximum value, you can say
Mm-hmm.
I'll calculate 1 by maximum value. That means
Yeah.
indirectly minimum value.
True.
Okay. So because for me, because why we are doing wantedly we are doing, because we already have gradient descent, which one gives you the minimum value.
True.
You take same thing. You take minimum value. You do 1 by minimum value. That will be maximum value. Same thing you are getting. Any
True.
which way. Simple techniques. Okay.
Yeah.
So now, yeah. So but and also one more thing, one more problem here is we have one drawback, which if we multiply large number of these values 0, 1, we get something very small to 0. Okay. Yeah.
Okay.
It's even in the small data sets itself, how many values you have? See, 892 values, 892 rows, you have
Yeah.
a small sample
Mm-hmm.
data set. But in the
Yes.
actual case, you will have lakhs of data. Okay.
Correct.
Now, what these values will always be 0, between 0 and 1. Correct.
Yes.
There are
Yes.
probabilities. Okay. The sum of these two values will be 1, and any value will be always between 0 and 1.
True.
So now if you multiply, let's say 1000, 0.0101, the value will be very 0.00, almost negligible.
Yes.
Correct. So to avoid that, what we are doing is we are introducing log.
Okay.
Okay. So log of AB is log A plus
Log
log
A plus log B.
is
Yes.
log rule. Okay.
Yeah.
So now log of this maximum likelihood, that means A into B. So log of 0.8 into 0.87 is log of 0.8
Log-
plus 0.7.
True. Yeah.
Okay.
Hmm.
But one issue is log of any value between 0 and 1 is negative.
Okay.
Okay. So log of
Mm-hmm.
any
Got it. Got
value of
it.
0 point
Got
between. Okay. So that means
it.
log of, let's also see, log of 0.
0.5. Hmm. Log of 0, 1.
Calculator. Yeah, log of 0. How much man? 0.
Log of 0 is okay.
Log of 0.5
Minus.
minus 0.3. Log of
Hmm.
any value between 0 and 1, they are saying, right?
Yes.
Okay.
Yes.
So between 0. I'll give 0.99. It is negative.
So minus 0. Yeah.
And I'll give the log of sorry, 0.001. It is also negative.
Minus 0.
Okay.
Yeah.
So that means any value between 0 and 1, because our probabilities are between 0 and 1, and if you put any value, it is negative. So to make it positive, we are using one more additional negative sign. Okay.
Minus negative. Yeah.
So log of 0.8 will become minus log of 0.8, and this is also minus log of 0.7.
Yeah.
Okay. So
Mm.
here when we take maximum likelihood and do the
Mhm.
summation of negative log, what we get is
Yeah.
loss entropy. This is very, very
Okay.
important word. Okay. Even in after machine learning, when you go to deep learning also, you will have some
Mm.
losses. These loss concepts are very, very important, Karthik. Okay. Because in
Okay.
most of the interviews, they mainly see, I'll tell you, see in sigmoid, any algorithm,
Mhm.
mainly what they'll focus here is the loss functions. Okay, because if you understand loss function, that means you are actually understanding it. Because to understand these concepts, everybody will think, okay, I understood sigmoid function. It is simply small function greater than 0.5. I'm putting a line equating, that's fine. But the main crux is always in the loss function. Even in the
Okay.
or it's a linear regression or here on feature or mainly in deep learning also. If you understand log functions, right? Then interview
Yeah.
will also think, okay, you are understanding some stuff. Okay.
Okay.
So here you have, yeah, so in one of the loss is this cross entropy. Okay, now what is
Okay.
cross entropy? It is simply summation of negative loss of maximum likelihood. This is
Okay.
our maximum likelihood, correct?
Mhm. Mhm.
On that we use log,
Mhm.
on that we have summed it,
Yeah.
and we have given negative value. Okay, so
Yeah.
it is simply summing of negative log of maximum likelihood. Okay,
True.
why maximum likelihood? Because we want the maximum probabilities. Why log? Because if you use only maximum likelihood, the value is going to be zero when you multiply a lot of zeros. That's why
Mhm.
you're using log. Why negative of log? Because log of any positive value between 0 and 1 is negative. So to make
Yeah.
it positive, we are using negative, one more negative, and we are summing it. Okay. So what is cross entropy is simple summation of negative logs of the maximum likelihood.
Yes.
Okay, so if someone asks you what is maximum cross entropy, if you say this, they'll be really impressed. Okay, then they'll ask you, hey, what is okay, fine. They can ask you what is maximum likelihood. You can say, hey, maximum likelihood is these are the probabilities, but not the actual probabilities, but not the probabilities which are getting from the sigmoid function. Okay, but the
Hmm.
probabilities which the point is actually it is. Okay,
Hmm.
so it will be same for the positive point. There is no effect, but for negative point, you should not directly consider the probability from the sigmoid. You need to separate it from one so that you will get the actual
Mhm.
probability of the negative class. Okay,
Yeah.
those are the maximum probability. And you multiply, put log, do negative so that you will get cross entropy. Clear?
Yeah.
Okay. So now, maximum likelihood, we need maximum value.
Hmm.
Okay. But here, since you have used negative, we want this minimum value.
Yeah.
Agree? Directly, if you're using positive value, but here you use negative, right? So negative of something. So you need lower cross entropy.
True. And
Fine?
also here, Sankar, that
Yeah.
each and every one probability is we are getting from one coordinate. I mean, right?
One
Each
data
and every
point.
point, one
Correct.
data point.
Correct. So
Yeah.
this, for example, this particular row, first row, let's say this is my y variable, right? B is my y variable.
Hmm. Yeah.
Remaining everything, let's say all these are my x variable. Okay.
Yeah.
X, yeah. So these are, see, perfect question. So when I'm saying here WIXI, see, if
Hmm.
I go back, see W1, X1, W2, X2,
Each
these
and
are not
every point.
X1, X2. What are these? These are this.
Yeah.
This is X1, X2,
Yes.
X3,
Yes.
X4. What are X
Yes. Yes.
coordinates?
Yes.
Features, whatever the feature we're taking, right? So one row. So if you plot
Hmm.
it in the space,
Yes. Yes. One row.
10-dimensional space, one point in the space, that is one row, one data
Yeah.
point.
One record. One
Yeah,
record.
one
Yeah.
record. Yeah, one record, one row. You take that
Hmm.
one point and that you can represent in this equation W1, X1, W2, X2.
True.
Okay.
True. True.
That
In such a way,
value,
we will get one prediction. I mean, one
correct,
probability.
correct.
Sigma
So that
probability.
value you put in a sigmoid, you will get one probability. That is,
Yeah.
that is, for example, 0.8 for first row.
Hmm.
From that, you will get the its negative probability.
True. So in such a way, if we take that example, we have to get by using this 892
Correct,
probabilities. The
correct,
summation of 892 logarithmic properties,
correct.
everything,
Exactly,
we will
exactly.
get
Perfect,
final one. Based
perfect,
on that, we'll get line.
perfect, perfect.
Oh,
Based upon
true,
that, it will give the line. And again, if there are any misclassifications, it will shift the line.
true,
Will shift the line. Okay. But interestingly, you don't need to do all this. There is you will
true,
know
true,
just
true.
in just 5 to
Yeah.
10 minutes. You will know. Okay. But
Mm-hmm.
you are not learning the behind background.
Yeah,
Okay.
yeah, yeah.
All
Yeah.
this will become automatically. Okay. That we'll see in just 2 minutes. Okay. Now, clear your doubt.
Mm. Yeah.
Fine. So now our goal is to find out that line which will give us the higher maximum likelihood or lower cross entropy.
Mm-hmm.
Okay. Fine. Now the prop here, what the final equation what we are going to get here is, if you observe in this equation, so we are using, this is what, this is the actual class. That means, for example, this
Yeah.
is a positive class, we're taking the positive probability. If it is negative class, we're taking its corresponding negative probability.
Yeah.
Okay. But this positive class will also have negative probability, a small, like 0.2.
Yes. Yes. Yes.
Negative class will also have the probability 0.3. So
Yeah.
what we are doing here is, in the final equation, so we are considering the probability of the point actually, that is also, we include the other point, other part. That means, see, for every
Mm-hmm.
point, okay,
Mm-hmm.
see, this is the final logistic loss. Okay, just like how
Okay.
we have linear regression loss function, right?
Okay.
The final, if anybody asks you, right? So the final logistic regression loss is, for each and every point, you are taking the actual class, the point that is, okay, yi,
Mm-hmm.
into
Mm-hmm.
log of
Probability. Yeah.
probability plus
Mm-hmm.
it is probability of other class. I don't know whether it is positive or negative. I'm just taking
Yeah.
some
Yeah.
class. It's probability. The other class, one minus
Yeah.
other class
Mm-hmm.
into that
Into
probability.
log of 1. So here we are taking both the
Both,
classes.
both for
Yeah.
every point.
Yeah. Got it.
Okay, that plus this both. Okay,
Mm-hmm.
and you are doing the average. Okay, you are doing,
Okay.
anyhow you're using the minus. Okay, you are having this
Mm-hmm.
minus. We're taking one minus
By
and
average.
by
Number of
average,
points.
because you are some doing, yeah, average loss. This is average loss. Okay, and this is
Okay.
here from 1 to n. In this case, it will
Got
be
it.
1 to 892.
Right.
Okay, so this is the loss. So if anybody asks you, for example, even if you logistic regression, yeah, loss function also, this will be the loss. Okay, in different formats they will write.
Yeah.
Usually
Yeah.
when someone sees, right, so they get scared. Okay, but since you already know, it is speaking about the same thing. Yi minus yi. See here, what they said is, they took minus inside, but
Mm-hmm.
single main thing you should focus is class into probability, and one minus that particular class into log of that probability. That's it. You can write
Mm-hmm.
any form. See here also. Uh, one second. Yeah. So minus they took inside. So instead of n m
Mm-hmm.
they said m. Okay. Yi into its log of that, and 1 minus y into log of that. Okay. The notations are a bit
Mm-hmm.
different. That's it. You should not get scared by
Mm-hmm.
this. For example, some other. Okay. Same minus 1 into log y into log of this probability into 1 minus y into this probability. Anyway.
Okay.
Okay. Some they
Okay.
use this pi. Okay. This is not the thing. Okay. Any loss. Yeah. Here also same thing. Okay. So if someone asks you, this is also called as log loss or binary cross entropy.
Okay.
Okay. So because usually it's used for binary classification, right? So binary cross entropy,
True.
why it is called as cross entropy. Okay.
Yeah.
And it's also called log loss because you're using log loss,
Okay.
anything. Fine.
Okay.
So this one you should remember, Karthik. Okay. So this is
Mm-hmm.
the final logistic regression loss. And I hope that you know each and every, you can explain each and every bit. Why, what is 1 minus why we are doing, why we are doing this, everything.
Okay.
Right? So it is minus 1a of simple class into log of that probability plus 1 minus class into log of 1 minus that probability. Fine.
Yeah.
Now what happens now, if you think about it, for each and every point, okay,
Mm-hmm.
it will take that point,
Mm-hmm.
okay, if it is 1, okay, 1. Let's say you are having 1 comma 0 or 2 classes, right? So for one
Mm-hmm.
particular point, it is 1 into log of what is the probability of this class. You are going
Yeah.
to get it from the sigmoid. That
Sigma band.
okay, this P of y you will get it from sigmoid. Okay,
Yes.
probability
Yes.
plus
Mm.
1 minus
0.
1 minus
Yeah.
1.
Directly. Yeah.
Okay, into log of what is the probability.
Opposite probability. Yeah. Same
Correct.
point.
Now, if it is other way class, okay, I consider this one, right? If
Mm-hmm.
it is other way, if you consider 0, so this will become 0.
Yes.
So plus 1 minus 0 into log of its probability. If you
Yeah.
understand, anytime you are actually only one part is getting used.
True.
If it is class 1, this will become 1. You lose this, only use this.
True. True.
If
True.
it's class 0, directly this is become 0, this is using. Okay. So
Yes.
anyhow, you are using only one part based upon the
Yes.
class
Yeah.
and its probability.
Yes.
Correct. So that's why they have included into one equation.
Both. Yes. Yes.
Okay.
Hmm.
Yeah. So I hope you understood that. Okay.
True.
So
True.
for one, when you're using one, this, and for 0, uh, 1 minus 0 will be this, and 1 minus probability of this. Okay. And
Hmm.
and
Hmm.
and whatever we understood, right? So that is also getting valid if you observe. See, for
Okay.
class 1, See, so let's just summarize this and close this. See, we are having class one, class zero. Consider class
Mm-hmm.
one. For class one,
Mm-hmm.
what probability we want? Only the direct
Higher
probability.
probability. True.
So for one, I'm putting one here, and directly whatever the probability from sigma, I'm going to get log of the probability. Cool.
Mm-hmm.
Plus
Mm.
1 minus 1, 0. This is getting closed.
Yeah.
Okay. But class 0, what probability I want? I don't want probability directly from sigmoid. I want 1 minus that.
Yes.
Correct? So for zeroth class, this will become 0
Yeah.
plus 1 minus uh,
Zero.
0. This will be 1. 1 minus 0 is 1 into log of 1
Lesser probability. One minus
taking.
at higher probability. Yeah.
1 minus probability. You will get higher probability. Correct. For
Yeah.
negative
True.
class, the sigmoid probability will be 0.1, 0.2 lower. So when we are doing
Yeah.
1 minus that, we will get a higher value. Let's say 1 minus
Mm.
1, 1.1, 0.1. Okay, this will be higher. Same thing what we studied here,
Yeah.
right?
Yeah.
We want the higher, same thing. We want the higher values for lower, correct? It is getting implemented automatically. For positive, anyhow, it is taking. For negative, you are doing 1 minus 5. So both are mixed
True.
into one and one final equation.
True.
Clear?
Hmm.
Perfect. Okay, so that's why this is the log loss, which is handling everything, what all we studied from yesterday, right? So everything
Hmm.
that is happening in just in one this equation. So you can
Yeah.
simply visualize that now any new line, it will do that sigmoid function, okay, whatever WIXI sigmoid function, take that probability, now put here
Yeah.
and put here, put here, take the value, plus go to second point, put here, all do everything, average, you'll get one loss.
Yeah.
That is for line 1. L1, you got some loss. L2, you got some other loss. Okay. So now which one you are going to pick? The one with the,
Higher one.
you want higher loss.
Last. Sorry. Last should be minimum.
Correct. So this should be minimum. Okay. Forget about this maximum likelihood. Okay. All that we
Yeah. Yeah.
understood.
Yeah.
But finally, now this should sit in your mind. Okay. The final thing you
Yes.
got
Yes.
loss.
Yes.
And this
Yes.
should be
It should be minimum.
minimum.
Minimum. Minimum.
Okay. Fine. So now this is a logistic regression loss function. And since we have this, the only task is to find the weights for which we give the minimum loss. Okay, this is
Yes.
important.
Yes.
So we started
Yeah.
with what? We started with this W. All this time, I was telling you that W1, W2, all this you know automatically.
Yeah.
You started with some random value, but you know, so you will come to the best line. Okay.
Yeah.
Finally, what we're trying to find, you are trying to find a line. That's it,
True.
which will give you the least loss. And that,
Yeah.
but this line will have some values. What are the values? W0, W1, W2, etc. Right?
Hmm.
Your aim is to find these values. That's it, nothing more. Such that my
Got it.
loss will be least. That's it.
Got it.
Correct. So now we will see how we are going to get these values. From where are we going to get these values, these W values? Okay.
Okay.
So
Okay.
now simple. So our aim is to get the least value of this loss function such that it will give you the weights. Okay. For this, we are going to use a gradient descent technique. Same thing because I
Okay.
already
Okay.
taught you gradient descent. So you can refer those. Okay. But the
Okay.
concept is same. Whether it is
Okay.
gradient descent, just like how sigmoid function it will give you value, gradient descent, whatever linear regression, logistic doesn't matter. So it will just give you the least values. Sorry,
Okay.
not least values, least loss.
Okay. Yes. List cost.
A line which is given
Whatever value might be anything.
correct.
Value might be higher or whatever, but
Exactly.
final function it
Correct.
should give the minimum.
Correct. Okay. So now that's I would say regarding the logistic regression. But just summarize, what we are doing. First, we are going to calculate the score, apply
Mm-hmm.
sigmoid, calculate.
Sigma out, calculate loss, adjust rates. Yeah.
Okay. But how we are
Again and
doing?
again
How we are doing? So okay, we are doing it for few times until your loss.
until when delta becomes a very
We
small.
are going to see here. You have the good thing. Okay. First thing.
Hmm.
This is a overall quick summarization. So
Yeah. Yeah. Yeah.
ask you about linear regression, right? So these are the main
Hmm.
steps, all steps. First, you are any point, okay, any point you take from this row, that point you compute the score Z.
Mm-hmm.
What is the Z? Z is WIXI.
Yes.
This you take that, and next you pass this Z through sigmoid.
Sigma function. Yes.
This is
We'll get
sigmoid.
the probability.
This is get the probability. That is
Yeah.
the probability is y
To
hat.
the class one. Yeah. Y hat.
This is the
Y
y.
value.
Okay. Now measure how wrong the probability is. That means loss. Loss is what? Minus y of log y log this
Mm-hmm.
probability plus 1 minus y into log of 1 minus this probability.
Okay.
Correct? This from here you will get loss.
Yeah.
Here you got predictions, only predictions you got. But
Yes.
based upon the prediction, you don't know there could be maximum misclassifications or in best case no misclassifications. I don't know.
True, true, true.
But that's why you will use this loss. Okay. Now
Hmm.
since you got this loss, our aim is to reduce the loss.
Okay.
How you will do using this?
Yes.
Okay. Same
Okay.
like when you go to gradient descent, how we have done um, for example, W, yeah, see here. W, you started with some random values of B and W. So W new, sorry, M and B. M new will be M old minus learning rate into slope.
Yes.
What is initial values of M? Random value, any value.
Hmm.
From that, you can then you did minus into learning rate into slope. From where you are getting
Yes.
the slope? Slope you are getting it from the gradient descent. Okay.
Yes. Hmm.
Uh, yeah, the slope is what? Yeah, dou L by dou M.
Yes.
What is this L? L is my loss function.
Loss function.
What is my loss function? You know, right? Actual value minus predicted value square root.
Yes.
We have dou L by dou LB. So then you do derivative of this.
Yes. We
Derivative
get
of
M and B.
respect to M. You get one thing.
Derivative with respect to B.
B. You get the equation. Okay. Like
Yeah.
that, when you do this and do separate it from old value, you get new value. With new value, that means you getting new line.
Yeah. Correct.
Correct? New value of M and new value of B means a set of new values of M and B means new line. With that new line,
Yeah.
again, you will do the same process again.
True. True.
Correct? Same thing is will happen here also. Just like how you have those values here also, you got this loss. You got this loss, right? That loss
Hmm.
you are doing derivative with respect to W. Here only one W, but here how many W's you want? Those many W's you need to do. Okay. For example, this W1, W1, W1. Okay.
Hmm.
W1 O new equal to W1 old minus learning rate into derivative of this loss function with respect to that W old.
Okay.
Okay. This you when you solve this derivative and get some value and multiply with the learning rate, and then you separate it from this old value. This old could be initially random value. You will get some
True.
value. That is the new value of W1 new value.
Okay.
Similarly, you will have same equation and you will get W2 new value. Like that, let's
Yes.
say W4 new value. So four new values,
Yeah.
that means you got a new line. Earlier the line is this one. From there, now your line became this.
Okay.
With this line, when you're changing line, everything will change. That means the
True. True.
some values, some points can be falling here, some interchange might happen. So the predictions will be different. If predictions are
True.
different, loss will be different.
Yes.
Correct? You will get a new loss.
Yes.
That new loss
Yes.
again you will put here. Again you will calculate
We
this. Again you
will
will
get
get
it again.
new values.
Hmm.
Set of W1, 2, 3, 4, you will get set of new values. That means a new
Yeah.
line.
Yes.
Correct? So that means you will repeat the same process again and again, again and again, again and again. Okay.
Okay.
Same thing. You'll do this step again and again until the loss becomes very small.
Very small.
Okay. For every new line, it is trying to give how it is giving you a new line with less loss because we have
We
introduced
have already taken the. Yeah.
we have introduced gradient descent, and the job of gradient descent is give you the lowest value of
Low.
the loss.
Yeah. Got it. Got it.
So that's why it is giving new line with a less loss.
Yes.
Okay, it
Yes.
is constantly trying to fit such that a new line that is having the least loss.
Yeah.
Okay, and
Hmm.
that loss, and you will get that line right. So that value coordinates whatever you are going to get W1. So that is a best line which is separating
Okay.
best. That means indirectly it is learning the coordinates right from
True.
random W1, W2, W3, W4. It is learning, and finally it is fixing at best line.
Yeah.
That's why it's called machine learning.
Got it.
What it
It's
is learning,
learning.
if
Yeah.
someone asks you what it is learning, it is learning these coordinates. How it is learning?
Coordinates. Yes.
With this loss function minimization technique, gradient descent, it is learning new values because we have fixed it a goal that give me least loss function.
True.
Okay.
Yeah.
So these concepts I would say you should keep in mind, and now it should be clear like this only these steps will happen every
Hmm.
day. Okay.
Hmm.
And
Hmm.
repeat again and again. So such that you'll get the line. Okay.
Yeah.
Yeah, this is what logistic regression I would say. Okay, this is logistic loss. Okay, and sigmoid function is also called logistic function, etc., etc. Okay, and but one good thing is you don't need to do any of this at all. Okay, and even in
But we should know.
yeah, but you should
Yeah.
know. Okay, even
Yeah.
but tomorrow we will see code. Okay,
Mm-hmm.
Whatever you studied, right? It is one single line, just like how we did it in linear regression. You
True,
just
true.
import logistic regression, pass it, train, fit, prediction, accuracy, done.
Yeah.
You don't need to
From the
do.
stream, yeah. Can you please, these 5 steps is there, right?
Hmm.
Quick summary. Can you please link with the data points in the Excel sheet Titanic? Just to take 1 hour to like, I mean,
Now,
just in a random way.
shall I show you?
Yeah, yeah.
See, to take this point, for example,
For example, what I
you
mean, we have to go through each and
correct,
every point, right? If 802 points are there,
correct, correct. See, correct.
so all points at a time it will take, or one by one. For W1 X1 means first record, or W2 X2 means second record. Or how it will do in the background. Did you
Yeah,
get my point?
yeah, I got your point. So, see, no, initially it need to calculate the loss, complete loss,
Correct. Correct.
loss of that particular line. Only then it will go to the next line.
Okay.
Okay. So
Mm-hmm.
it will do this for each and every point.
Mm-hmm.
First point. Okay. Then it will calculate, each point will go through this equation, and then it will go to through sigmoid
So
and
there W1 X1 means from the, for example, go to Excel sheet once.
okay.
Here X1, X2, X3 means all these features.
Correct.
Okay. If P1 plus
Let's
all
say
the
that,
features.
yeah, these
True.
these are the x values, and let's say this is my y
Y
variable.
value. Y value.
So now when I'm saying W1 X1,
Mm-hmm.
it is W1 is
Mm-hmm.
some random value. Okay, let me say 0.5.
Okay.
How we will find out that we saw? Finally, the logistic regression will give us what are the actual values of W, W1, W2, 3. Okay, initially
True.
random value. What is
Yeah.
X1?
Random value initially.
X1
X1
is
is the
3.
P3
3.
and X2 is the name. Sorry, not name.
X2
Age.
is, for example, I'm not considering the name. Name is not useful.
You
W2
can consider.
is,
Yeah.
let's
Age
say
you
some
can
0
consider.
point, no, it cannot be 0 point also. It could be anything. Let's say 20. W2 is
Mm-hmm.
20. This is
Mm-hmm.
not probabilities, right? There no
Yes,
room
yes.
0 and 1.
Random value.
Into X2. X2 is what? My second feature. Second feature is, let's say, age 22.
Age. Yeah.
Okay. Like
So
that.
likewise, it will calculate first point.
Like that. For first point, it will take this W1. This is called summation of WIXI.
Summation. So all points it will.
Yeah. One by one, it will send to sigmoid. At a time, it cannot send, right? One by one. First, it will take WIXI of this one.
Mm-hmm.
Because for sigmoid is, for
True,
sigmoid,
true.
it will give one input, only one output. It cannot give 10 inputs to sigmoid, right?
Correct,
So
correct.
first take this, do WIXI,
Mm-hmm.
okay, and send it to sigmoid. Now sigmoid
Sigma.
will calculate and it will give you a point of 0.5. Sorry, some value,
Correct.
some
First,
probability.
first record. Yeah, first record. It will give the XA. I mean, first point.
First point. Okay.
Hmm.
Now what happens is, based upon this, you are having you'll get a probability. Okay, let's say my
Mm-hmm.
probability is 0.7. Okay. As
Mm-hmm.
of now,
Mm-hmm.
we are putting a threshold of 0.5.
Yeah.
Correct? Now,
Hmm.
0.5 threshold means greater than 0.5 or greater than or equal to,
Yeah.
I'm saying
Class
class.
one. Class one.
Less than, I'm saying class 0. Okay.
Correct.
So now this is
Mm-hmm.
categorized into class 1.
Yeah.
Some other, okay, that is done for this
Hmm.
point.
Hmm.
Take another point that is classified into class 0. Like that, so all values you have.
Yeah, 92 points.
Oh, 892 points. Fine.
Hmm.
Now you are having this loss function.
Correct.
Okay. But are we using that loss function directly? No, you are using derivative of loss function. You're doing dou L by dou W. That means what?
Yeah.
We are doing differentiation of loss function with respect to this D. Just like
Correct.
we did. So now what is my loss function? This is my loss function. So you will do dou L by dou W, means you will do this different y with respect to dw, log of this W, log of this, log of this. So you'll get
First.
some derivation over here.
Mm-hmm.
Okay. So in
Mm-hmm.
that, whatever the value you are going to get, right?
Yeah.
That value, you finally will get some value.
True.
Okay. Some numerical value you will get, because
Hmm.
why? See, the loss value is this. Okay. And when we are doing this dou L by dou W, okay, whatever the, when you use the partial differentiation, correct,
Yeah.
you will get some other equation. Okay, just like
True, true.
I'm not doing here because
Yeah.
for example, if you see here, we have done it here. See, this is
True.
okay, we are not directly putting here, we are doing dou L by
Correct.
dou B.
Correct.
That
Correct.
means what, this do 2 will come here, and the partial
Mm-hmm.
differentiation of
Constant
this,
will be
and
zero. With
similarly for
respect
dou L.
to B only. Yeah.
Okay, in this you are going to replace the values. my actual
Correct.
value, my actual input,
Mm-hmm.
corresponding values. Similarly, here also,
Okay.
you do the when you do this dou L by dou W, you will get a new derivative equation of this line. Okay.
Mm-hmm.
In that,
Mm-hmm.
whatever the values like the actual y or the predicted y, you are going to replace.
Okay. Okay.
You are going to replace it.
Mm.
Okay. That value, you are going to get it over here.
Yes.
Then
Loss.
you will multiply with what is the
Again, double double.
standing rate.
Mm-hmm.
Okay. You are going to get this one.
Yeah.
That will subtract it from the old value. That will give you a,
Okay.
sorry. That will give you a new value of this the value. The same thing you'll also do for all other coordinates.
Yes.
Okay. Now this will happen for all 800 points. Loss will also be calculated for 800 points.
Mm.
Okay. And finally, you will do the derivation of this, and then you will multiply with the learning
Okay.
rate.
So for each and every record, for example, 892 points are there. So for each and every record, we'll get a line, new lines. Yeah, how many times it? I mean, based on what? I mean, for example, it is doing different probabilities for 892 points. For each
Correct.
and every point, we'll get one probability.
Correct.
Okay. For each and every record, we'll get from loss after doing differentiation.
Correct.
Okay. So, in such a way, is it number of lines formed is directly proportional to number of data points we have?
No, see, for after considering all the points,
Mm-hmm.
one change of W will happen. Not for every, so not for one point. It is, see,
Mm-hmm.
when you are
Go to Excel sheet. Yeah, I will easily understand. Excel, that Titanic
huh?
thing.
See, after yeah, after considering for all these points, okay,
Mm-hmm.
then
Mm-hmm.
one change of W will go from W. See, from W it will go to W new W1 for example.
New.
After considering the values of
Yeah.
all the points. Okay, first of all, it should calculate loss for all the points, right? Just from one particular point, if it calculate loss, and it cannot change the line because only
True.
this
True.
line could be fault, but all remaining are perfect. It cannot do that. So it will calculate the loss for
Yeah.
all these points, and based upon all those
Yeah.
points, the derivation will happen, and then that will shift
True.
the coordinate. Similarly for other points, similar for
Okay.
okay. So the
Okay. Okay.
shifting to new coordinate from
It's
W1.
an average. It's an average of. Yeah. It's a.
Correct. So it is shifting to new coordinates. It is after considering the loss of all the points. It will
Yeah.
consider the
Yeah.
loss of
Got it.
all the points, then it will shift to the new coordinate. Then again from there it will consider the loss of all
Got
these
it.
things, then it will shift.
Yeah.
Okay.
Yeah. Yeah.
Okay, man. Fine. Any doubts?
No. No. Clear.
Okay. Fine. So I would say this much understanding of sigmoid, sorry, logistic regression is good enough. Okay, for you to
Mm-hmm.
even
Mm-hmm.
attend interviews. But usually, even if you don't know this much, also that's fine. Okay, normal people will understand what is sorry, what is logistic regression is. First thing that will come into their mind is sigmoid function. Okay, it is a
Mm-hmm.
function
Mm-hmm.
that means you take the input. Just a summary. Sorry,
Okay.
just summary. You pass some input and the value you'll get, and it as per the threshold 0.5, it is going to predict. From the predictions,
Yeah.
you will get the loss. Okay, even if you explain that much is also fine. But if we start asking, then having this background knowledge is also helpful.
Okay.
Okay. Fine. Yeah, you can go through the class again and just note down whatever the doubts you have. Okay. I hope I am able to clarify what you are told. Okay.
Yes.
But
Yes.
you can just note down, and tomorrow class, I'll just show you the code, few examples of logistic regression and something called hyperparameters. Okay. So, but first 10 minutes, we can take whatever the doubts you are having. Okay.
Okay.
Fine. So I just suggest you to just go through the class once because when we are in the class we might sometimes feel like we know, but next time when you are going to the class, right, go in point 1.5 speed or 2 speed in YouTube. Okay,
Mm-hmm. Sure.
and
Sure.
then just note down whatever doubts you have. Okay, but
Yeah.
this equation is important. Okay, just focus on this
Sure.
equation.
Sure.
Okay,
Yeah.
fine. I would say that's uh for today. Let's
Yeah. Sure.
Okay.
Thank you.
Bye.